Hi, this is a quick video to show you how to take a polar graph and turn it into a polar equation if it's one of these limicones that's of the form r equals a cosine theta plus b, or it could be r equals a sine theta plus b. Now, because these things can be like ambiguous, I'm going to make it so that a could be anything, but b has to be greater than 0. Otherwise, there could be more than one answer if I could let b be negative. So here's the first question, and it's a dimpled limicone, so we should expect it to have b is going to be greater than absolute value of a. But let's just see, I have a technique that I'm going to show you. One way you could do this is to take the extreme points, the highest point, the one that's further, the one with the greatest r value, and the one with the smallest r value. And notice how those are located at about, in this case, at like 190 degrees, and at 270 degrees. And if I graph those, this is r and theta. If I graph the theta as kind of the x value, and the r as the y value, it would look like that. 190 or 90 degrees comma 1. And then here it's 180, here's 270. 270 would be all the way up here at 9. From this picture, we can also really nicely see this point, that it's at, that point is 5, 0 degrees. So that's going to correspond to the point 0.05 degrees. Sorry, 0 degrees, 5. And there's also a point over here at 180, which is going to correspond to this. So we're able to, and if I wanted to, at 360 degrees, it's back to 0. So we can see that the 5 points would look, if I graph these 1, 2, 3, 4, and then back to the 5th one. So it appears to be y equals something negative sine. So what's a and b? Well, a is negative because it goes, it hits its minimum before it hits its maximum. And the b value is just going to be the middle line. And the a value is going to be the amplitude, which in this case is 4. So that's one way to do this, but maybe, so the answer is going to be r equals -4 sine theta plus 5. But another way you might do this question is to notice the high point of this sine curve is located at b plus absolute value of a, because that's sort of like the b value is in the middle and the a is the amplitude, but it's negative, so we do absolute value instead. This middle line is at b over here, and the bottom line is at b minus absolute value of a. Now, I can create the equation without drawing this picture, with making some decisions. The first one is, do you think this is sine or cosine? And the answer is that this would have to be a sine because its maximum value is on this kind of like this y-axis. So its maximum value is at 270, and that happens on a sine curve. Sine curve has maximum values at either 90 or 270, depending on whether a is positive or negative. Cosine has maximum values at 0 or 180, depending on whether a is positive or negative. In this case, the maximum value is at 270, so this is a sine. Second decision is that a is greater than 0 or a is less than 0. And in this case, if it's sine, a positive a value makes sine achieve its highest point at 90. But this is at 270, so it's going to be a is negative. And now here comes the good trick, which is this. The high value is going to be b plus absolute value of a, and the low value is going to be b minus absolute value of a, and the low value is 1. And then if you add these two equations together, you get 2b equals 10, or b equals 5, which is also what we got here. Then we can we can plug into here and say 5 plus absolute value of a equals 9, so absolute value of a equals 4. But we already established that a was negative. So a is negative 4, b is 5, and we end up with this equation again. Now these lines here that I made, these sort of like top line, bottom line, I could draw those as circles just to show you what that would look like. There would be a big circle here with 9, and there would be a small circle. Those kind of like, that's what these two horizontal guidelines become. Okay, one more example. I'll use both methods. The first method, or the second method, I'll do first though. Cosine or sine. Because this reaches its high value at either 0 or 180, it's cosine. Because it's 0, reaching its highest value, instead of 180, a is going to be positive. Now, 8 is the high value, 8 comma 0 degrees. And the low value, well, it looks like it's a 2, but it's actually not. When you have a limacon with inner loop, it's really negative 2. So this point here could be thought of as 2 comma 0 degrees. But we already have 8 at 0 degrees, so it must be negative 2 comma 180 degrees. And that's why the low value is negative 2. So you say b plus absolute value of a is 8. B minus absolute value of a is negative 2. Add those together, and you get b equals 3, which means absolute value of a equals 5. But since a is greater than 0, a equals 5. Now you might like to do it the other way, where you make the equation by drawing the other graph. So let me show you what that looks like. So here's what this would look like. We would say that this point here is important. It's located at 8, 0 degrees, which on this graph would be located at 0, 8. Also significant is this point here, which looks like it's at 90, 3. So here's 0, 90, 180, 270, 360. So at 90, 3, there's a point. There's also a point over here at 270, 3. And this point in the beginning could also be thought of at the end as 360, 8. But the complicated point is this one. So that point is at negative 270, which would be graphed here as 270, negative 2. And we connect these to form a cosine curve. And the b value is just 3, which actually we could read right off of this graph here. And the amplitude is 5. So this curve is y equals 5 cosine x plus 3, which makes this thing r equals 5 cosine theta plus 3. I again drew these green circles. The green circle is a little confusing in this one because this outer green circle kind of corresponds with this top line. And the inner green circle is at really r equals negative 2, which makes the same circle as r equals 2. But I drew those in. And, okay, so that's good. So that's what I wanted to show you.